Okay. Good evening, everybody. It's Naveen joining the call. Can you guys hear me? Could you please type in the chat window, guys, if you can hear me fine? Great. Thank you, guys. So welcome back, guys. Hope you guys had a good vacation and holidays and a good festival. Hope you all had a good time. A lot of guys were traveling out of town, so we thought we'll just give a little break there. Can everybody hear me fine, guys? Could you give me a quick yes, please? Thank you, Sriram. Thank you, Mohan. Thank you, guys. So let's get started without any further delay. Let's come back here today. What I would like to do is, here last time in previous session, we talked a little bit about how we create a model. We looked at linear regression model. We looked at a few models, the ARM, the clustering model, and also the logistic regression, guys. Today I want to focus a little bit on a slightly lighter topic, which is on data cleaning and the data wrangling part of it. And I want to take you slightly into deep. Most of the time, 70 to 80% of the time, generally in the world of data science, we spend on data cleaning or data wrangling, guys. So we'll try to get a feel of it. That's what we'll be doing today. And I have uploaded all our stuff in our GitHub, guys. Please check that one. I will probably show you at the end of it. But let's come back and get started here, guys. Here is a quick look at the life cycle of data science. Let's see. Let me bring up my tool if I can find my thing. I can't find my thing. Okay, so let's see, guys. Here are some of the high-level steps. The data acquisition is the first step, followed by data preparation. Then we have hypothesis and modeling. That's where we are most of the time using our statistical skills and things like that, trying to prove the hypothesis and things like that. And then we have the evaluation and interpretation, followed by the deployment and operation and optimization, guys. Let's briefly look at some of these techniques and try to get a feel of them, guys. Okay. So the first step is data acquisition. Data acquisition is where we are trying to acquire the data. Many times in the world of data projects, what happens is the organizations may have the data within their internal organization. Sometimes they may not even have the data. Imagine a scenario where we have a group of apartments data. So here is the price of an apartment, and here is the apartment name or number. Here is the number of beds, floor number, criminal rate per year, probably in that colony or in that location, the pollution level, distance to nearby education institution. Okay, most of the time in a state scenario, we're interested in the price of an apartment. The price of an apartment may depend on. Do you think based on the apartment name or number we can say the price of an apartment, guys, or do you think it is important? Based on the apartment number, you think the price will depend on, guys? Okay, there's one more time. Can you give me a guess if you are able to hear me properly, guys? Sorry, some of the guys are not able to hear me, so I'm just checking. Thank you, Vishnu. Thank you, Srikant. Niharika, thank you. Okay, so now back to one more time. Do you think the price of an apartment will depend on the apartment number, guys? No, it's pretty obvious. What about the name, guys? Do you think the price of an apartment will depend on the apartment name? Okay, sometimes it depends on the builder and things like that. So some popular builders, the top builders, and things like that. But I think this year a lot of real estate took a hit, but I think it is slowly picking up, and hopefully it will be back to normal, guys. Do you think the price of an apartment will depend on the number of bedrooms in an apartment, guys? Okay, obviously the more the bedrooms, obviously the more the price. What is this? This is our thinking. That is nothing but the hypothesis, guys. What about the floor number, guys? Do you think the apartment will depend on the floor number on which? Do you think the ones on the lower floors or the upper floors will have this? Looks like a lot of you guys have an idea here. The answer seems to be yes. What about the criminal rate in that area? Do you think the criminal price has fluctuated based on the criminal rate? I don't think any of us would like to buy an apartment in an area where the criminal rate is high. We all like to be that is one of the most important things than anything else, safety and security, guys. What about the distance to the nearby educational institutions? Do you think the price will depend on that? how far the schools and colleges are. If you're a little bit, if you're married and things like that, if you have kids and things like that, that becomes obvious. Obviously, you'd like to be in a place where you're much more closer to an apartment and things like that, guys. Okay. So here, the most important variable is the price. Most of the time, we are generally interested in predicting the price. The price may depend on many other aspects. Here, we have only some aspects of it, guys. Okay. So what is this? This is the thinking of general thinking. This is the thinking in a statistical, mathematical, or maybe of a data science world. Generally, what we tend to think and what we try to understand and things like that, guys. So here is some data. Imagine you went to a real estate organization. They have done some data. That is good. But imagine you don't have data. What do you do? Well, you'd call a few apartments, builders. You can collect the data. What is that? That is data acquisition. Imagine these are some of the variables we have collected the data. 30 lakhs, here is apartment number XV, or maybe the size of it, number of bedrooms, the floor number, second floor. The criminal rate per year is 3, pollution level is 15. We miss that. The price of an apartment will also depend on the pollution level, guys. If the pollution in area is more, I don't think we would be interested in buying that, or that would not be preferred. And distance to education, we have talked about it. So that is the first data acquisition. It involves acquiring the data. Sometimes you may acquire the data by them, different builders taking a survey for them, and or maybe you might not go, but somebody might go from apartment number, and then they will collect the data, guys. Okay, this data could be also from logs and servers, social media data, census data. So that is generally referred as unstructured data, guys. Unstructured data is generally something which is not in database and things like that. We have briefly talked about it. Then comes the data preparation. So if you look here in the data, there are some issues, guys. If you take each column, price looks okay. 30 lakhs, 20 lakhs, 28 lakhs, and things like that, it looks okay. Name seems to be okay. Room seems to be okay. But floor number, notice most of the columns seem to be numeric, but there is one column which is saying it's G. It's indicating textual data, G for ground floor. And then the criminal rate per year. Criminal rate per year, the low criminal rate, maybe the higher the number, the higher it is. So it looks okay. All of them seem to be numeric data. Again, there seems to be in pollution levels, some of the apartments don't seem to be having the pollution level data. So that is called missing data. If you take a look at this one, the column is a little too large. I don't think we need something with that big. It might be a small thing for you at a logical level, but generally we don't give such big names. You don't give a definition of a column. In the column name, you tend to give something short and sweet. What is that? That is data wrangling. Trying to identify issues like that is data wrangling, data preparation, data cleaning. The other names of that. It is a process of cleaning and unifying messy and complex data sets. So we call this as messy data. Data after reformatting can be converted to JSON and CSV. Okay, you fix these kind of issues, then you convert it to whatever is the standard format in a company, in a business, in an enterprise. Sometimes most of the companies today will follow the JSON or the XML formats, guys. That is data preparation. Then comes the modeling part. Modeling part is where we are really trying to dig deep and understand the price of an apartment. It may depend on the number of bedrooms, the criminal rate, and the pollution, but not the remaining. What is that? That is my thinking. What can you do? Well, you can take this data, you can build a model. We have seen how to build a model the previous week. And then what do we do, guys? The thinking is the hypothesis, the modeling, the statistical modeling will give us an indication of the correlation and the causation. That is where we briefly talked about p-values and things like that, guys. Okay, I will not go too deep into those things, but that is the modeling stage. It involves for forming and testing hypothesis about the data. So this is where we may actually talk to the business. In an enterprise world, you may have a business team. You will talk to them. You will try to understand what is important, what is not important according to them. And then we'll use the machine learning techniques to tell them, hey, it looks like, statistically, this seems to be important, this doesn't seem to be important, is what we try to convey to them. So that's where we form the hypothesis. Hypothesis is, your general assumptions and things like that. You try to prove it or you disprove it based on the p-value, guys. Okay, this is where we will use Python, R, and Spark for the machine learning algorithms and things like that. And then we try to evaluate and interpret, guys. If time permits, we'll also look at some of the evaluation strategies, maybe tomorrow or day after tomorrow, and try to understand some metrics, accuracy, sensitivity, specificity. These are slightly advanced topics, and I may confuse you a little bit for the first time, guys, but we'll try our best in simplifying them in the coming up days, guys. Model performance, that's where we try to understand various metrics such as accuracy, sensitivity, specificity, ROCs, and all those things. Those are yet to come. Then we deploy. Deployment is where we are actually thinking, hey, we built a decent model which gives us good accuracy. It is making good predictions, and so we can go ahead and try to actually use it in a real world. That is where the deployment strategy or deployment step comes in, guys. Okay, so we'll do a little bit of exploratory data analysis. It is nothing but the data preparation, data wrangling. All these steps are part of the exploratory data analysis. Today we will try to look back at the hard data set that we referred in the previous session, and we'll try to do a little bit of visualizations also, guys. Okay, so EDA is a pre-processing step to understand the data. There are numerous methods and steps in performing EDA, but we'll look at some of them, guys. At a high level, cardiovascular disease is the data set that we're looking at. It's about the heart diseases. They are the number one cause of the death globally, with 17.9 million death cases reported each year. So cardiovascular diseases are nothing but the heart diseases, guys. They are concretely contributed by hypertension, diabetes, overweight, and unhealthy lifestyles, guys. I'm sure you can understand some of the common terms here. Tension, is overweight, and unhealthy lifestyles is one of the. So at a slightly coding level, the first step that we do is we try to import and get to know the data. So let's see, come back here. Come here. I've been trying to review the techniques I documented here, guys. So here is some of the imports. We will go ahead and set a working directory. So I'm using a slightly different laptop or computer because I'm at a different location today, guys. So I'm hoping all things will go well, but let's see. So here I'm just doing the imports, guys. Import is where you're saying, hey, I need the operating system, the pandas for data frames, NumPy for matrices and arrays, matplotlib for visualization, Seaborn for Seaborn we have not talked a lot, matplotlib we have not talked a lot due to time constraints, guys. I wanted to focus more on the data modeling and the data cleaning part of it rather than the basics of the visualization, because I just wanted to give you a quick more feel. You can look at other workshops and other things like that for the details of such basics, guys. Okay, so here is a data set, heart disease prediction. One more time, something we have earlier looked at. So we have a few columns: age is age, sex is gender, 1 is probably male, 0 is female. CP, I think it stands for chest pain, that is blood pressure. This is cholesterol. This is, I think, blood sugar. This is something related to ECG. I do not know what that is, but we'll have a quick look at it and a few more things. And at the end, we have something called a target. Target means this guy had a heart disease. 0 means, 1 means yes, 0 means no. That is what you can think of, guys. Okay, so let's come back here. DF shape, if you recall, what are we doing? We're trying to understand how many rows and columns are there. 303 patients and 14 columns. Everybody with me so far, guys? Can you give me a quick yes, please? Okay, sorry about that. I think maybe I rushed up a little bit. Forward about that. So if you ask the data frame, what are your columns? These are the columns. Yes, and we can say info. Info, if you recall, is nothing but the metadata. It is indicating, hey, it's a snapshot of all the things that we are individually looking at. There are 303 rows, 14 columns, and it tells you 303, 303, 303. So if these are something less than 303, that means there are some missing values. It does not look like we have any missing values here, guys. They're all non-nulls. Some of them are integers, which is numeric. Float is nothing but decimal, is what it is. But we need to go a little bit deep into, guys. Let's come back here. So generally, some of the things that we do in data cleaning is you check the data types. You try to verify if the data types are, are the numerics being reported as numeric, or sometimes the textual data are being, or the numeric data are being reported as textual, or vice versa. You check for the data mistakes, any invalid values in the data. You check for missing values. If there are missing values, invalid values, you try to replace them. You check for the duplicate rows. You try to get a basic summary. The statistic summary is the basic summary. You try to understand, get a feel of how many outliers are there. If there are any outliers, you remove them, guys. Okay, so let's come back here. So that is what these are. This is what we are looking at. If we say df.u for every column in the data frame, notice here it tells you age has 41. So let's say if we come back here, variables, okay. So in other words, more precisely, age has 41 because age is a numeric column, and 41 unique value people are, of different ages. Sexes 2 means it's like 1 and 0 probably. Probably 1 is male and 0 is female. So if I come back here, there you go, guys. Age is in years, sex is 1 is male, 0 is female. CP stands for chest pain type. Typical angina, atypical angina, non-anginal pain, and asymptomatic, which means, I think if you briefly recall, this is probably they got the chest pain because of the shoulders, neck, maybe the back resulted, and asymptomatic is something, they didn't even have an indication. Suddenly they had a chest pain. I think that is what this refers to, guys. As a, again, we don't need to be the domain experts, but the general understanding is generally what we try to get here, is what the chest pain. Then the BPS is nothing but the blood pressure. That is next column. So if you take a look at this, here is the blood pressure, 49 types, chest pain is 4 types. CP and sex, again, they are actually only 2 and 2 types, and I think right now Python is thinking these two are integers and integers. Okay, but if you actually look at, the domain, it looks like these are not the numerical values. These are actually the categorical values, which is the textual data, guys. So that is what you try to understand. Which one seems to be each column? When it says, say it's a numeric, is it really numeric, or should it really be textual or a categorical data? Is what we try to understand. Then next one is blood sugar 0 and 1, FBS. Again, the Python thinks it's a numeric value, but it really looks like it's a 0 and 1, which is categorical. Cholesterol, again, that's in milli. And if you look here, cholesterol has 152 values, so that is numeric is okay. Then you have ECG 3. Generally, if you have 2, 3, 4, 5, limited number of values, they are probably categorical. Come to rest ECG, 0 is normal, 1 is having wave abnormality, and so on. 2, definite ventricular hypertrophy. So that's the categorical data. Thalal, maximum heart rate achieved. That's about 91. 91 means a lot of values. That's a numeric value. And again, this seems to be categorical. Exercise induced, yes or no? Old peak 40, that is probably numeric. Depression induced by exercise. Then we have slope again. Slope is 3, that's probably categorical. Target is nothing but 0 is disease, 1 is no disease. So if it is a 0, they have some kind of heart disease. In heart disease, heart attack is one kind of thing. There are other kinds of heart diseases also. If you recall, we briefly discussed about them, guys. Again, we are not domain experts, but a general understanding. 1 means here no disease. Generally, it is the other way around. 1 means having a disease, 0 means no. But either way, it looks like that's a categorical data, guys. Okay. So in other words, most of these numbers, which seems to have small number of values, seem to be categorical data, but Python seems to be thinking they're all numerical values. So what should we do? We should correct them. We should tell Python, hey, these are not numerical data, but these are categorical, which is, look like as if it's a textual data. And that's what we'll do, guys. So one more time, if you say df.d types, here, it will give you the data types. Say it's thinking everything is numeric, which is integer or float, is what it is, guys. So check the data types. So now here is the binary: sex, blood sugar, exang, target. These are binary, means they have 2 values: 1 yes or no, 0 or 1, true or false, on and off, and things like that. So these 4 variables need to be binary according to our understanding. Categorical is when you have more than 2. CP, rest ECG, they're also textual data, but there are more than 2 values. So all these things need to be, so we need to go back and tell Python to do. And continuous means these are numeric. 1, 2, 3, 4, 5, only 5 columns are numeric among the 14 columns is what we have here, guys. 14 or 10 columns. So let's see what we have here, guys. Let's come back here. What we will do is, this is where we are telling, hey, here is sex. Sex is gender. What do? Convert it to object. Okay. So let's say, for sake of simplicity, come here. This here. We'll run this one. Before we run this one, here is the gender or the sex. Python is thinking it's integer. We'll run this one. and then we'll run d types. Notice now it's converted to object. What was earlier a numeric has been now converted to an object. So this is how we're telling it, hey, this is textual data, don't convert it. Why is it important? We'll try to understand that in a moment, guys. Okay, we're also going to take CP, chest pain, blood sugar, ECG, that is something related to exercise, I think, slow, CA, and things like that, and then we'll convert all these things to object, which is nothing but, there it is, wherever you see an object, we have converted. We have explicitly told Python, hey, these are nothing but the categorical or the textual data, guys. Everybody with me, guys? Following me? Quick yes, please. Okay, so let's see, come back here, but we have ca.unique. Let's see what is special about CA here. So feature CA, feature means the variable, guys. It ranges from 0 to 3. Let's step back here. So here we go, CA, number of major vessels is 0 to 3. Looks like there are 3 or maybe 4 values there. So if we say n unique, find the 4 and change them to NaN. If you say n unique, in other words, let's say, come here, it's giving us 4 values. So here we go, 0, 1, 2, 3, 4. But actually it looks like 0 to 3 are the valid values. So what is 4? 4 means there are some invalid values. Okay, so if you say value count, what will it do? It will go ahead and tell you there are 5 values which have a value of 4. The count is 5 and the value is 4. Rest of them seem to be okay, but this seems to be corrupted data or bad data. This is what is bad data. This is what is corrupted data. So what we will do is put a filter, try to look at all the rows, and we are looking at CA. So if you, let's say, scroll here, there is CA 444. So what's happening? This is a filter. We're asking the data frame, give me all the rows where this value is equal to 4. Okay, guys. So now what we are going to be doing is, we know this is bad data. The bad data is corrupt data. So what we will do is we'll put something called np. Wherever df.loc in the column CA, put it as np.nan, that is like null values, and then we'll verify what these are. So first I'm going to run 2 here. I'm going to run this, and then I'm going to run this. So what happened now is, these are all these rows wherever there was CA was 4444, we have introduced a null, np.nan, not a number, like an or read as not a number. It's like a null value, guys. So now what we will do, if you say unique, if you check for unique, so now 0, 1, 2, 3, whichever was 4 has become a NaN. We can also come back here, check for value counts, each value. It does not list the NAs. When you're doing a value counts, it doesn't detect it internally, so that's why it only gives you 0 to 3. But what is NA? There are a few rows which are still NAs is still null values, which is nothing but a bad data only, guys. We come back to data frame, we go back and ask him, hey, do you have any null values, and give me the sum. Notice what it does. What it will do is it will go to each column. In age, in all these columns there are no values, but it introduced 5 null values. Who introduced? We introduced. What is that? This is where we try to understand a little bit about the domain. That, hey, the value 4 is not a valid value for CA. So what we are doing is we're trying to correct it. We're in the process of correcting it. So we introduce some special null values here, guys. Let's come back here. So there is the thal. We will repeat the same thing. Thal has 0, 1, 2, 3. Ranges from 1 to 3. So 0 is not a good data here. The range is actually, valid range is 1 to 3. So 0 is not good. So what do? We'll repeat the same thing. First verify the unique values. Okay, 0, 1, 2, 3. And here is the value counts, each value. So there are two of them which have a 0 in that column. So if you try to identify the 2 rows, passing the filter, there it is. So find the thal. Here is thal, there's a 0, that means this is invalid data or corrupt data. Okay, so what do? Replace them with NaNs, and you try to Give the filter again, you will not get anything. Say hal.unique. There it is. Okay. Then what do? You ask the data frame, hey, now how many null values do you have? It'll say, notice now we have introduced 2 for CA. I'm sorry, 2 for TAL and 5 for CA. So we manually introduce this. What is this? This is the process of data cleaning, guys. We are identifying some of the bad data. We're trying to replace them with np.nan, which is a standard practice. So ideally what we would need to do is, we would need to spend some time and try to identify, sit with some business expert and try to identify all these columns. What are the possible rules? These are a couple of rules. In a real world, you will have tens and tens of such rules. What you need to be knowing is, do you like this kind of work? What you're doing is not heavy programming. You're not writing a 10 or 100 line programming just to correct one thing. These are all small filters. You'll be doing tens and tens of times. For that, you need to have a little bit of understanding of Python, data frames, numpys, arrays, and matrices. Everybody with me, guys. Quick yes, please. What you need to understand is, do you like to do this kind of thing? If you like to do this kind of thing, that's good. Then that is, that's a good one to look at, and things like that, guys. Okay. So now, generally what we do is, one of the techniques is, you can tell a data frame, fill NA. Fill NA means fill wherever there's this NA, which is like a null value, df median. You can also use mean, you can also use linear regression. There are some more advanced techniques, but most common technique is mean or median. And before that, so let's see, we'll execute this one step. So right now we have CA and 5, TAL as 2. So if we say this, and now you verify this, notice CA is back to 0, TAL is back to 0. What happened is, whichever were the null value, they were don't knows, what happened? They were replaced with a median. For that particular column, it will calculate the mean, or here in this particular case, we calculated the median. The median is replaced as wherever there's a NA. What is that? That NA is the one. This function identifies, more precisely this function or method identifies the NAs, which are like the null values, and then it's replacing with the median. That's a standard practice, guys. So that is what we do. That is nothing but cleaning again. Another technique, if we come back here slightly at a documentation level, checking for the missing values. So we check for CA and TAL and replace them. Then we check for the duplicated. We can say df.duplicated.sum. So this is where this here duplicated will give you a number. So so it looks like there is one row which is duplicated. Okay. So let's say this is just as a simple if else. Let's come back here and see keep duplicated. So what we are saying is, here are the duplicated rows. It could be possible this whole thing is the data of one patient. Maybe mistakenly a data entry. The person who was doing the data entry entered the same person's data 2 times. So you don't need the same data 2 times entered. Or it could be possible this is probably another patient exactly with the same kind of data also. We can really go into that level and try to understand them. But if the 2 rows are exactly the same, then statistically or mathematically they are not very useful for us for statistical analysis. What we can do is we can remove them. That is what we are trying to do here, guys. Okay. Here, describe is nothing but the basics. Let's see. Here we should on the min and the max value for the categorical variables, min and max. So here's sex, CP, FPS. These are all the categorical values. We should see it will give us the min and the max. So look at sex. The min is 0 and the max is 1. It's a categorical or a binary. So what you are trying to again ensure is, for categorical, you just make sure it is not giving. If there are values between 0 and 1 and you suddenly find a 2 here, then that's an invalid value. You just double check it here. Okay, then CP, I think min 0 and max rating, that looks okay. Ideally what we'll have in a real world here, for the sake of simplicity, we are maybe taking 10, 12 or 14 columns here, guys. But in a real world, you have hundreds and hundreds of such columns. In each column, you need to be diligent. You need to spend some time. You need to you need to spend a little bit of time, give a little bit of time, be patient, and try to analyze this kind of things is what you need be doing, guys. Okay, and okay, so you basically try to, if you come back here, you try to ensure CBS is 01 ECG. Min and the max values are there here, is what you try to understand. These are all for categorical values. Then you have the minimum numerical values. So let's say, come back here, take a look. We have patients who are anywhere from 29 years up to 77 years. What is, well, these are all the patients who have some kind of heart disease. It looks like patients are only 29 years old. It's very surprising. Very young people are also, 29 is like young people, very young, right? Even young people are getting some kind of heart diseases. Again, maybe unhealthy lifestyles and things like that is one of the reason. Then if you recall, 25%, 50%, this is nothing but first quartile, second quartile, and third quartile. And then there is a standard deviation, that is nothing but the variance is what it is. So what is this? For numerical data, you try to understand. When we say, hey, some people who are just 29 years old are getting some kind of heart diseases, that is not the most greatest insight or anything like that, guys. But that's just interesting. It's just interesting to know that some people who are young, and some people 77, on an average it's 54 years, around 50 years people are, they're getting this one, the heart diseases and things like that. So ideally, what is the chest pain? Again, chest pain is probably categorical. Blood pressure. What is it? Blood pressure. So ideally, 94, some people have 94 blood pressure, some people have 200 blood pressure is the maximum. On average, it's 131. So for us, it may not make sense, guys. But if we explain to maybe a physician and things like that, that might be interesting for them. Oh, okay. I see some people have low blood pressure, some people have high blood pressure. And this is the range there where it's fluctuating. That might be insightful for a physician, guys. Okay, these again, we are not the experts in a healthcare domain, but these min and maximum values may end up being insightful for them, is what I'm trying to convey here, guys. Everybody catching the point, guys? Quick yes, please. And that's what we do, guys. You ideally sit with one or two business guys and you try to explain it to them. Hey, this is what is happening. Ideally, we'll come up with some kind of presentation. Each of these things will plug them into a presentation, and we'll try to display them there, guys. Okay, so let's see, come back here, come back to the target. The last one is the target. So if you take a look at target here, this is the target column, ones and zeros. One means here they don't have a disease, zero means they have a disease. So that is not very explanatory. So what we are doing is, for the sake of simplicity, we'll say wherever there's a one. Oh, okay, I think I'm doing the reverse here. Wherever there's a one, let's put they have a disease. Zero means no disease. And then if we, or let's say, we first execute this, put this back here. Now you look at target, disease and no disease. Wherever there's a one, it's replaced with a disease. Wherever there's a zero, it's replaced with a no disease. What is this? This is called data cleaning. This is called data wrangling. You're just making the data a bit more presentable, guys. A group of patients which are, so similarly we can go ahead and say wherever there's a one, put a male, otherwise a female. Zero is a female. So let's say there is sex. We'll repeat that for CP. 1, 2, 3, 4 values will also repeat for exang, slope, thal. And now at the end, these are all the categorical data. If we do a describe, notice now what we have is, here it is. We do not, it does not. When you do a describe, it does not really show you any of these things. Sex, CP and things like that doesn't show you. Why? These are all numeric, these are all categorical. It's only showing the numerical values. What we need to do is, you need to say include object. You are saying describe means the basic or statistics. Okay. For categorical data, it is indicating, hey, there are 303 patients, 2 unique values. One is male, another one is female. The majority of them is male. 200 out of 303, it looks like 207 patients are male. Okay, so most of the patients who seem to be getting heart disease is a male. Ideally, you can come up with your own reasoning why males get more heart diseases than females. Maybe that's thinking. That's an assumption that we can translate it into a hypothesis. We can go deep into that kind of thinking, guys. So again, CP chest pain. It looks like top one is 0, 143 times, and exang we don't know, slope I don't know, thal disease. 165 patients out of 303, 165 patients have disease is what seems to be the majority. So describe, this is the basic statistics of the categorical data. Categorical data is textual data. Everybody following me, guys? Quick yes, please. Okay, and let's say come back here. Okay, let's get into a little bit of visualization, guys. Okay, so here is df.plot. So that's a slightly at a numerical, at a textual level. A plot kind equals to box. This will give us a group of box plots. And if you notice slightly carefully, trust BPS, this is blood sugar, BPS. So what you try to identify is, notice those dots here, those small bubbles. This indicates there are outliers. We briefly discussed, if something is greater than 3 standard deviations, it's an outlier. And this column has outlier, this column has outlier, outlier. There's only 111 here in these two, but a few outliers here. So ideally, you just get a feel of it. What is outliers? And take a look at the mid one, the median is what it is. But if we go a little bit deep, here is the box plot. Another, we're using an SNS, is a seaborne library. This is target and cholesterol. 0 disease means 1, no disease means this thing. Now if you spend a little bit of time here, guys, take a look at this. On an average, these are all the patients. Cholesterol, there are few outliers here. What this is indicating is, if you take the average or the median, it's, let's say, close to 240. On an average, the cholesterol level is 240 for the patients who have disease. And it looks like even if you take the patients with no disease, they're also close to 240, which is like 250. In other words, there is not much difference, which is no difference, which is like null hypothesis is true. In a statistical world, if you go back into the statistical terms and things like that. So we can say maybe cholesterol, in the group of patients that we have, maybe cholesterol is not really contributing to the heart disease a lot. This is with respect to the group of patients that we have. We have only 300 patients, but in real world you may have 300,000 patients, and these averages may differ. So visualizations give you a correlation, guys. So it looks like, so what is that? You're trying to get a feel and understand, hey, is cholesterol really contributing? Imagine you sit with a physician and you're telling, hey, all the patients who have a disease, who have on an average their cholesterol is 240, and the cholesterol level is 240. These are the patients who have disease, and the patients who do not have disease also, their cholesterol level is coming to be 240. What is that one? That might, at a slightly in a healthcare domain, maybe a physician might be thinking, hey, cholesterol, people with more cholesterol have a lot of chances of getting a disease. But it looks like our statistical analysis is reporting that it is not having much disease. What is this? This is visualization. Okay, but remember, if you remember the mantra, the correlation is not causation. That's where we can go one step deep. We can dig into a much more statistical test or a machine learning algorithm, and we can try to look at the p-value. We have briefly looked at that in the earlier ones, guys. I will not go too much into that one, but I'm just trying to refresh your thoughts. Sometimes removing these outliers will also make a difference. I'm not sure if I have that step here, but let's take a look at another old peak. I don't know what this is, but let's say a bunch of outliers there. And now notice there seems to be some good difference here. The average of the people who have disease, there is some good difference here. So it looks like maybe whatever this column or feature seems to be having a difference. But again, we need to remove the outliers, guys. That's what we'll do. So here's a little function. We're going to take the continuous features. Continuous features are the numerical data. Everybody with me so far, guys? Quick yes. I don't expect you to be perfect. But what I'm trying to do is I'm trying to get you a feel of, again, how we will work with each of these columns and things like that is what I'm trying to give you a feel of it. You can kind of go back and try to practice it later. But let's see, so these are categorical data. Cholesterol or peak, not necessarily. One of them is categorical there. So let's come back here. Take a look at this. Here is continuous numerical data. Age, blood pressure, cholesterol, ALK, and whatever the total peak is. And we have a little function here. This is going to take the data frame. It's going to pick up each of the columns, and it's going to extract the column. It's calculating the Q1, Q3, quartile 1 and 3 and interquartile range. It's multiplying IQR with 1.5, to identify the outliers. And here is where it's doing its calculation to identify the outliers. And what's it doing? If we would like, we can also remove the outliers. That's what this does. So if we give the continuous features, which is nothing but continuous variables, take a look at this. Age, we don't have any outliers, but for blood pressure, I think that's blood pressure, we have outliers. Cholesterol, we have 5 of them. That one has 1, that one has 5. There are some outliers, guys. What we can do is, we can come back here. We can say, we can pass that argument equals to true. What will that do? It's removing all the outliers. Then what we can do? We can verify. One more time, say, are there any outliers? We're verifying it. All of them are zeros. So we remove. Then what we can do is, let's come down, go back here, and we'll go back and further cholesterol here. Now take a look, guys. So again, there still seems to be some cholesterol. It's not stored box plot. Unsurprised. DF. These things should not be here. I'm just wondering why the outliers are still coming up. Let's see, run this one. Oh, some outliers are still coming up. So that means there's a bug. That's a bug. I've removed the outliers here. Maybe, what am I doing here? DF out. And what did I do? I have passed in the actual data object, but it looks like the outliers are still coming up. Okay, so I need to go back and fix that, guys. Okay, so again, those are the kind of things which might be given to you as work for you as data scientists. Somebody worked on, they removed the outliers, yet the outliers are still appearing, is what is happening, guys. Okay, so that might be a bug, and you might be expected to fix a bug. I will not try to fix it now, but and I won't confuse you, because I may myself play around a little bit with that. So let's go and see next step. Let's see what we have here. So 159 patients have the disease, 125 patients do not have the disease. That is what is going on here, guys. What we are doing is, we're doing a value count. Value count is telling you each value how many times it's appearing. We're doing a bar plot here. So take a look at this. Again, whatever you're looking visually, numerically, you're trying to visualize that. That is a characteristic of a data scientist, guys. Whenever you see a value count, what you can do, you go ahead and do a plot bar. This is saying heart disease classes. What is heart disease class? Having somebody has disease, somebody does not have disease is what we are referring as a heart disease class. Then come back here. Let's take a look at the gender. Again, 199, most of the patients seem to be male than female. We don't know why. Can you think of reason why most of the males seem to be getting the heart disease, guys, more than female? Any thoughts? In place equal to, I see just one. Good one, buddy. Maybe I should have just added that argument, but let me not play around, just in case I am into. But that's very good, just one. You remind me, and keep it up. Can you think of reason why more males are getting they are more hardworking, more males, okay, more pressure, more stress and things like that. I think if you recall from our previous things. And let's see what else we have, guys. Okay, so what are we doing? We're trying to visualize each one. Chest pain. Let's see what we have. Chest pain, guys. Chest pain distribution. Majority of them have a 0. So let's say, if we'll say atypical angina means, let's say these are the guys, these are the patients who have who got admitted, and what happened? Well, they had the heart pain, or maybe the heart attack. And let's say 83 is like, they also have a shoulder pain. 49, maybe they have back pain. 22, but whatever the 0 is, maybe they didn't have any pain. Maybe they are symptomatic. They didn't have any pain, yet they got the heart attack. 130. So what is that? We are just visualizing that. Okay, so you can individually visualize each one. ECG. Let's see, for the sake of discipline, we'll continue our visualizations here. ECG. Again, whatever this is, you try to understand, okay, this is extremely low. Very, very few patients seem to be having whatever this 2 represents. We don't know. Again, we are not healthcare experts. And I think this is something related to heartbeat rate, I think, guys. No ends. Exercise-induced angina distribution. It's slightly tough even for me to understand. So this is where we are manually going ahead and performing a value count dot. And here is count plot. Okay, we can select each of these columns which are categorical data. What we are doing is, if there are less than 10 unique values, at one shot we can go ahead and, so there is female and male. What is count plot? Each male how many and female how many? Again, that's kind of visualizing there. There's again the one in red. So just another technique making it a bit more attractive. And this is a characteristic of a data scientist, guys. Each one we try to represent, we try to talk in terms of colors and things like that. That's why it's called the most romantic job of the 21st century and things like that. That's for the categorical data. Then again, what did we do? Count plot. You can individually go ahead and the same thing if you like to. What's the gender again? So now, more precisely, this is bivariate analysis, guys. When you're actually to look at here, this is you're only looking at one variable. This is called univariable variate analysis. You try to look at one variable at one time. You try to understand. What you try to understand, you understand the min, mean, max, the mean, the median, how many are more, how many are less, which one is more appearing more number of times. You're focusing on one variable. But now notice, we're giving count plot. On x-axis, we're giving the gender, and here is the target. So target is nothing but the second variable. So this is like bivariate analysis. You're trying to analyze two variables at one time. Notice male. The green one is what is indicating the disease. What is it? Notice if we project this here, that's close to 90 of the males. 90 males got the heart disease, and if you project this here, it's only maybe 70 of the females. So the ratio, so roughly you can see more majority of the males seem to be getting the heart disease rather than the females. And the orange color, very few females have no disease is what it is indicating. And again, a lot of males also do not have a disease here, guys. Okay, so it looks like we do have the patients with disease. I mean target is disease and no disease. So we, out of the 300 patients, some patients do not have disease, some patients have disease, and what is it, guys? We have the percentage of the females, or the number of female patients is very less who do not have disease versus to the females who have disease is what this is indicating, guys. Am I making sense, guys? Are you getting a rough idea, guys? Okay, for some reasons, less number of females seem to be getting, compared to the males, less number of females are getting the heart disease, which is good one, which is a good reason. Chest pain, again, count plot, again, bivariate analysis. We are analyzing two variables at one time. So whatever this is, what is this one? We are interested more in the green one. Notice here what's happening. Atypical angina. Lot of guys, whatever this one is, atypical angina, they are close to maybe 70 of them or maybe 65 of them. This is the one lot of people reported. Let's call this, for sake of simplicity, a shoulder pain. People generally get the heart attack and things like that. Maybe they have a shoulder pain. Maybe they have, I'm just saying, cooking it up. They report it. So if you're constantly reporting a shoulder pain, you imagine you go in and tell them, hey, you better get a heart attack, heart test done. Okay, so that's what we're observing here. Count plot. So again, we're kind of visualizing two variables. One is the independent variable. The target is our dependent variable. That's what we're interested. Then take a look at the TAL. I think one of them is the heartbeat rate. It's probably the heartbeat rate, maybe. So whatever it is, whatever this one is, reversible defect. Notice the green one, that's at a very high number. You project this here, that's more than 120, whatever that is. So that might be something interesting. So in other words, there is some considerable difference. People, when they are reporting this kind of a defect, something is making a big difference here. So it's something to be kept in mind. So we can use it to form a hypothesis, we can use it. We can decide if it's. In other words, that's a slightly advanced technique of engineering and things like that, guys. We haven't really gone much into engineering, just some basics. So, but thinking loud here and trying to give you a feel. This is generally what we do in the world of exploratory data analysis. So again, Notice the green one. A lot of guys, whatever this one is, this is exact exercise induced angina. Maybe they're asking a few of the people to run on the whatever that one is called, run or walk, and then they are taking some metrics based on the sensors and things like that. Treadmill, guys, that's what I meant. Hue is the color, guys. The color is, the green color is the disease. It's giving disease green color to that one, orange color, slightly orangish color to that one. So it's kind of becoming the second variable there. Then I think the blood sugar. So notice again, for some reason I'm getting zeros and ones. I think, let's say this is green. So blood sugar levels 0, no disease. The people who do not have the blood sugar, this is 0 is probably blood sugar levels. Slightly confused, guys. I think something needs to be corrected here instead of 0 and 1. But that's close to, these are the patients. There are close to 140 patients who have disease, who have heart disease, and their blood sugar levels is low or maybe high, or whatever that is, guys. And let's see if I'm able to interpret this one. Sometimes it becomes really, really difficult because, again, we are not the healthcare, but that is acceptable, guys. We can check with our domain experts, and we can verify that is. Again, notice whatever that 0 is, that's contributing a lot. So ideally what you try to do is you try to get a feel. Hey, does it look like this could be an important variable or an important feature? You try to hypothesize that. Hypothesis means you initially, and you try to understand if that could be used to later. So here is count plot again in one shot. I think it's probably I'm repeating this one. The same thing. So a little bit of it, and then we have subplots here, all of them together, and let's see, count plot x equal to, see, all of them plugged in one plot. Spend some time individually, give it a little bit of time. So there it is. So looking at all of them, sometimes if there are too many of them, it gets a little too cumbersome. Try to understand them. So once you identify the top 10 or the top 5 variables, you can do them individually. If there are 100 or 200, you try to run something like this, it becomes really, really difficult is what it is, guys. I'm just plotting all of them. Let's see. So another way of visualizing, let's see, not this, here. So what are pie charts, guys? Okay. So 79.3% to defect. The only 3.7% are normal. 17% have a reversible defect. And these are the guys with heart disease. These are guys with no heart disease. But just another way of visualization. Pie chart, majority of them seem to be in this color. Reversible defect. Okay. And now we are getting a little core part of it, which is all the correlations in one shot. Give it a moment. So this is multiple variables at one time. This is called multivariate analysis, guys. In statistical world, when you try to look at multiple variables, you try to refer that as multivariate analysis. So this is like what you try to understand. So if you notice closely, the blue color bubbles is the disease, the orange is no disease, and you try to feel if there's a positive correlation, neutral correlation, negative correlation. It sometimes is not very, very obvious. Use another technique here, but you try to understand is normally distributed. Again, normal distribution, left skew, right skew. These are not the things we have talked in detail, but I think I just gave a very high level. Except the blood BP, yes, which is a blood pressure, which seems to be normally distributed in both have disease, and the one with no disease. Generally, if it is distributed, it is predictable, guys. So pay plot, you try to understand the distribution, and let's look at age and cholesterol. So in other words, you're taking on x-axis cholesterol, on y-axis you the gender, and then we're taking a column, the target, which is the dependent variable. If you run the LM plot, if you recall from our linear regression, You try to get a feel of it, male and female. What is this one? Target disease. In the group of patients, the blue color line, there seems to be a positive correlation between age and cholesterol. What's happening? As the age is increasing, the cholesterol is increasing, and what's happening? They are getting the disease, is what we can interpret from the blue line. For the female, the correlation seems to be slightly less positive compared to the male. So in other words, as the males age and age increases, their cholesterol increases, they have more chances of getting a heart disease, is what we can interpret this. And again, this is in the patients which do not have heart disease. Take the blue one is a female. As the age is more, the cholesterol is less. Notice that's a negative correlation, and they are not getting heart disease. And the blue one, I'm sorry, I think here the blue one is, I interpreted that as male, but that is really female, guys. The blue line is a female. In females, as the age is increasing, their cholesterol is increasing, they have more chance of getting heart disease. And in the females, notice the negative correlation among the patients who do not have disease. I think today I'm not able to use my tool, guys. That's why I'm manually moving my arrow here, so arrow and mouse here, because I'm using a different laptop. So there's a negative correlation. As the age is increasing and the cholesterol is less, they don't have. So among the females, if their age is more, and if they have less cholesterol, then they have less chance of getting the cholesterol. That's again a hypothesis which seems to be coming out from the visualization. These are some things you tend to get more and more comfortable as you get used to it, guys. Here, because this is a quick workshop, I'm probably going to explain you once or twice. But in real world, we'll do this tons and tons of times, and you will tend to get a mastery of that, guys. Okay, you'll automatically get a feel of it, and you'll become a master of such things. So again, what I'm trying to convey is, I'm not trying to scare you. I'm not trying to say that you have to get perfect. Whatever I interpret you, that should make sense to you. That should give you a feel of what kind of work you're looking at, what kind of work you'd be doing. And what is this? This is only one or two columns, guys. We'll be doing this for tens and tens of such columns in real world, is what I'm trying to convey. 0 is no sugar. This is what we have, cholesterol. This is not sugar or thing. This is cholesterol. Here's what we have. 1 means they have a disease. 0 means they do not have a disease. What is this one? This is heart disease. This is not diabetes. Oh, that is Amar. Okay. See, again, cholesterol, age, cholesterol target. But let's see. Okay, let's see what this relation plot. Okay, so that is thalac. I don't know what that is, but a touch of maybe a negative correlation as the age is decreasing. If you're this thing, I think we can also filter the data based on just the disease, the one with the disease, and understand if there's a positive or negative correlation. But a more important thing is all the correlations with the heat map. This will not only tell us which are important variables. So notice here, what's happening on the right hand side is, if you take a look at this one, as you're moving upwards here, it's becoming dark blue. That is 1.0. So what does that mean? Well, what that means is, as the intensity of the blue color is increasing, the magnitude is increasing. So if you notice here, on the diagonal you have all ones, that is correlating the same variable with the variable. That is not very useful. But if you take any of the blues which have slightly darker blues, so 0.39, that's a positive correlation between an age and a CA. More precisely, CA, whatever that is, chest pain. CP I think is chest pain, guys. CA I don't know. So here, as the color is increasing, the magnitude is increasing. As the intensity of the color is decreasing, the magnitude is decreasing. The more the lighter, the more the negative correlation. As one is increasing, what is the other which is increasing? As one is decreasing, what is the other one which is decreasing? It is not only are we able to visualize it in the form of color, but we are also able to look at the magnitude. And based on this, we try to understand which is a important variable versus which is not an important variable, which could be contributing to the dependent variable. What is this? Again, this is just one iteration. But ideally, we'll need to do multiple iterations and try to play around a lot, building models and things like that, guys. So that's a slightly heart rate achieved. Good one there. Okay. So again, because we come from different domains, we do not necessarily understand. But this is the story of the data. A group of 300 patients data is what it is telling this story. But you may get another 300, another 30,000 patients data. That you might find these values completely different. Okay, the more the data, the better it is always. Data beats the algorithm is the powerful mantra in the world of data science and things like that, guys. Okay, so then again, I'm just doing a bar plot. This is where we're trying to understand the visualizations and things like that. So let's see. I will just take up one or two more here. These are the value counts. So I think what we are doing is we are taking the top 10 ages, the top 10 values, and we are coming up and trying to understand it. Seems to be touching a little bit of normal distribution. You try to get a feel of it. And let's see what we have here, guys. Gender distribution versus target. Let me run this one. I will not explain each line here, guys. That's again, we'll leave it for maybe another visualization workshop or something like that. But again, the same thing. Say the distribution of the gender, how many people have disease. This is in terms of the percentage rather than the absolute values. So if you take the green one, 32% of the patients that we have who are male have a disease, have the heart disease, and only 23% of the patients who are female seem to have the disease is what is going on, guys. Okay, so if you add up this one, this is close to 38 plus 32. 70% of the patients that we have are male, and roughly 30% of the patients. Oh, sorry, this I think something is going wrong. Male and male. I think some of these things are being picked up wrongly. So I think one of them should be male, another one should be female here, guys. I think this is female because less number of females is what we have from the okay. Just pain versus target, a similar kind of thing, and so on, guys. Okay, so again, there's a little bit of explanation, but I'll leave that for you in the documentation part of it, guys. But let's see. Okay, so there is the AP skill development week 1, week 1 and 2. There's the basics of the Python. Here is the week 3 and the week 4 is where we are. Probably this week I'll be wrapping up, guys. I was actually supposed to wrap up last week. I do have some things that I need to take care of, and the scope of it is just to give you an introduction. What I would also suggest you and advise is you also look at multiple workshops and things like that which are being provided by the AP Skills workshop. AP Skill Development. Don't stick to one and don't expect yourself to be becoming a Sachin Tendulkar or anything like that, guys. I'm not trying to discourage you, but I would like you to go back and look at their previous workshops. I'm sure our team will be willing to share the links and things like that. Also look at them, also learn from them, and try to practice a little bit, all of them, and try to get a mastery into this one, guys. That is one way how you can pick up. So there's a heart disease prediction that I have completed, guys, and I have put up there. And let's see, gentlemen, ladies, questions time, guys. There is the GitHub link. Okay, one more time. There you go. Thank you, buddy. Try this one also, guys. Okay, any questions, guys? So today again, I don't know if it was too tough or too difficult and things like that. This week I'm going to introduce you to slightly advanced topics. I want you to be prepared. But today is a touch of data cleaning. 70 to 80% of the time in a real world data science or an AI professional, more precisely in a data science world, goes into this kind of techniques. And these are not really complex programs or anything, guys. But each column you try to take them and you try to work out, tens and tens of such rules that that will be there. Generally, it's a teamwork. It is not a one man army who would be working, but just visualize yourself. You're working tens and tens of such techniques, and that's what you'd be doing, guys. So the good thing is they're not complex programs. They're small filters and things like that you need to be familiar is what it is. And the bad thing is they will be different from scenario to scenario, domain to domain, and things like that, guys. So it'll take a lot of time, 70 to 80%. Optimization is where when you, Pawan, after you deploy it, you try to test and see how many predictions are coming correctly versus how many are not correctly, and then you try to monitor. You try to monitor on a daily or a periodic basis and try to improve more. That is where the optimization steps come in. Women play with men's heart more. True, you have a point. Women play with men's heart, men play with women's heart is also true, buddy. So but we also have to see what the data tells us. That is what is special about us, guys. How do we select an optimizer? You don't select an optimizer, you select a different modeling algorithm. The optimization process, you try to run multiple algorithms and you try to select a good one. And that is what my plan is. The next 2 days or maybe 3 days, I will try to give you a touch of those things. And those techniques, which is sensitivity, specificity, precision, recall, I'll talk a little bit about these things. Try to get you guys up to speed on them and give you a touch of it, guys. Pawan, thank you, buddy. Happy Pongal again, belated Happy Pongal and things like that. I appreciate that. And attendance link, I think Ansa will share it, guys. Deep learning, I will try just once. Because there are some advanced topics and my time is maybe the 2 or 3 days I'll be wrapping up this one, so I may not be able to get into deep learning and computer vision, but hopefully in the coming days we'll have a separate workshop for deep learning and computer vision, guys. Okay, so we'll talk about overfitting tomorrow, Ravi. Probably likely I'll give you a touch of it tomorrow. And gentlemen, ladies, does today's thing give you an idea, give you a feel of it, guys? Give you a feel of some kind of work that you're looking at and things like that. Android. Oh, that's a very detailed thing, Sandeep. I can't answer you in one quick thing. And no exam, I have not really discussed about that with our team, but I don't know if we're going to be conducting an exam or not. I will have to discuss that. Not 50%, but this week I'll be wrapping up, Sandeep. I cannot exactly promise you. So you have to forgive me, to bear with me. Okay. Again, there are other courses offered by Naresh IT, things like that in data science and AI also. You may also, after looking at some of our workshops here, also please consider joining their free courses also. And for a pretty reasonable the price also, they also have their own courses. You also can join them. Okay, that is probably what I would be talking maybe tomorrow and day after tomorrow, Santosh. 30 days, 4 weeks, Sandeep. 4 weeks is close to 30 days. That's how we go by. Okay. Okay, guys. Any other questions? Thank you, Santosh. Appreciate that. Thank you. Thank you, Jayalakshmi. Okay, feel free to fill the feedback, guys. As I said, for the vision and the computer vision and the deep learning, I think we will plan out a separate workshop, and you can look forward for the coming up days, guys. So there is a link from Sir. Please feel free to fill it out. Today, I will wrap up here, guys, and we'll continue the journey from tomorrow. Slightly advanced topics, so be prepared to be prepared for that. We'll try to simplify them and try to understand them, and we'll go from there. So signing off for today, guys. Thank you, and bye for now, guys. Thank you again, guys. Thank you all. Bye for now.